1, 2, 3, go! Hello everyone! It's been a long time, hasn't it? But CM Kosemen has been cooking up something big and extraordinary for you. Now we're gonna experiment with a new format for these podcasts. Now they're gonna be full of pictures and text and longer, I guess, and with more interesting stuff. And to begin with, just a couple weeks ago, one of you suggested me to do a video on the natural history and diversity of cephalopods. And I have just done that for this episode. Now we're going to talk about everyone's favorite animals, cephalopods. Now there's a kind of trend for these animals these days. All the basic people, that I know who are kinda interested in interesting stuff or kinda into science, this kind of I don't wanna point to anyone, but they're tentacles and cephalopods, they're cool, octopus, whatever. Okay, so that has been bugging me for some time because these animals are actually far more diverse than most people suggest and far more diverse than I realized when embarking upon this video. But I have made a promise and now I'm gonna keep it. So we are gonna talk about the ancient history, evolution, and present-day diversity of everyone's favorite strange terrestrial organisms, the cephalopods. But before, let's go back to the mists of time and see a couple of things that were not cephalopods, but weirder. Okay, so cephalopod evolution begins sometimes around the Cambrian period, where all life exploded into multicellular complexity. And of course, we got some really bizarre forms. For example, Nectocaris, a kind of strange animal with a head that resembled an arthropod and a soft body that resembled maybe a backboned animal, was hailed a couple of years ago as the first cephalopod ever. This is a squid. It was a squid ancestor, and there was a kind of gaudy press release to go with it. But it turns out that Nectocaris, actually one of the earliest animals in this selection, is not a cephalopod. Nobody knows what exactly it is, like many things in the Cambrian period. It was probably related to those great anomalocarid predators, but maybe a smaller and softer bodied example. So not a cephalopod, unfortunately, but something weirder and another material for a whole new episode, perhaps. Then in the Cambrian period, we got these very famous and very widespread fossils called Volborthella. Okay? So these guys, nobody knows what they are either. People say maybe they look like some extremely primitive ammonite cone or nautiloid, but no, nobody knows what they are, and it looks like nobody will. We have hundreds of them. They're so common that people even use them as indicator species to date sediments. But again, hey, maybe they're the cone-shaped shit from animal with a cone-shaped butt, but anyways. Then we got these weird fossils with an even stranger name called, spell this with me, Yoshellshionella. It looks like these basic music festival where you would expect to find a lot of basic guys or girls who's like, tentacles are cool, octopus are cool, I want to get a cephalopod tattoo. But Yoshellshionella looks nothing like these people, nor that imaginary festival. Instead, it's a bizarre cone-shaped shell with a pipe. What are you doing? What is this thing? It's probably an early snail-like gastropod, but probably not related to cephalopod ancestors as we know them. And to make something clear, cephalopods are mollusks. They are related to clams, snails, a lot of other things actually, slugs, conches. There was a famous Monty Python skit about the whelk. So yeah, that's also a mollusk and also a cephalopod relative. But of course, cephalopods are much different than all other groups of mollusks, which are also very diverse, but we won't get to them here. So let's go with the natural history of cephalopods after this break, in which I make sure that this new arrangement is recording properly. Hop. Okay, we are in the game. So, where were we? Yeah, we were talking about things that were not cephalopods but were previously thought to be early cephalopods. And now we're going to real cephalopods. By the way, there were a few more fossils and creatures in the previous category, and I know I missed out some of them, so bear with me here because this is going to be a very long and very diverse podcast. But also, please know that this is all my weekend's worth of research, and although I know the basics of cephalopod evolution and cladistics in general, I may have made small mistakes, so please point them out in the comments section. Okay, the earliest things we may actually call cephalopods are these things called Tannuella, which are like a proto-ammonite, if you will. They probably resemble these monoplacophoran neopilinas that we still have living in the depths of the ocean today. A bit like a limpet, but something very extraordinary in their anatomy. First, a muscular and well-differentiated foot and an oral cavity, surrounded by fleshy, almost tentacular tissue. Of course, Neopilina is a living fossil, and it's a highly divergent monoplacophoran, but suffice it to say that Tannuella was probably like this guy, but taller, and with chambers making up its shell as it grows along. Now these chambers and this shell are gonna be main parts of the cephalopod story for millions of years to come. Then there's a different group called Discosaurida. By the way, now I'm talking mostly in terms of groups, because if we were to talk about species, this podcast would be days long. So among the Discosaurids, there's something called Pragmoceras, with a very strange furled bottom part of its shell that people think may be the exhaust of a jet pipe, which is another cephalopod hallmark. So this is a museum model of Pragmoceras, and maybe it looked like this. Then we have a poorly understood group called the Ellesmerocerida, and I guess the only thing you need to know about these guys is that they began to evolve the rudiments of this chambered shell. So as the animal grows, it moves on to this compartment, and the old chamber is left vacant to act as a kind of buoyancy chamber. And, like the previous guy, Pragmoceras, this guy has a kind of furled shell, probably the exhaust for a siphon. But once again, very poorly known group. And then there are these things, the Oncocerids, which have a more complicated shell. And also in between these guys and these guys, I'm actually skipping over some fossils and groups, so bear with me. But among the Oncocerids, we can count Pomerantzoceras. I don't know if I'm spelling that correctly. Again, with a primitive stacking of chambers. And these are one of the rare fossils in which colors are preserved. So you could see these bands preserved on their shells. So I guess pinstripes were in fashion back then. More oncoquerids. This thing called Bottlenose is an example, and it's a way to show that this group was kind of beginning to evolve into these curved shapes, which we would see more of in the future. Now, these oncoquerids or these related orthocerids, this guy, Orthoceras, are kinda close to the family of the Nautiluses, but not quite there. You know, cladistics, if you know cladistics. If you don't know cladistics, I can tell you that it operates a bit like a stairway or a ever-branching tree. You can get close to a present-day groups, but there's always these outward branches like these guys and these guys that are not quite nautiloids as we know them. But then we have nautiloids as we know them. This guy, Cirrus, is one example, and nautiloids are somewhat similar to the ammonites, which we will see more of soon. But the main difference is that the nautilide body plan, okay, I'm going back a bit, the empty chambers stack up with a hole that opens directly through the center of them. Whereas in ammonites, a different arrangement is present. So as you can see, the chambers are stacked this way, and a neat opening runs through their centers as you get closer to nautiloids. And of course, they evolve slowly, and they got both straight and curly forms, but in older days, there were more straight up nautiloids present. This guy is a lovely form, Trilacinoceras. I'd like to have this on my fireplace if I had a big house with a fireplace. It has a kind of really arcane, kind of like trumpet of apocalypse quality to it. But of course, it belongs in a museum. And more nautiloids, you can see the curly shapes evolving in things like this Centroceras. And of course, the curly shape is completed in today's Nautilus. It's a very, very special living fossil that has a history going back at least to the Silurian or Ordovician periods, which is enormous. Now, if you look way back, okay, so you could see the point in which the Nautilus diverged is somewhere between the Silurian and Devonian years, more than 400 million years ago. Can you believe it? And these guys are still bimbling about in the world's ocean. This one is sucking the eye out of a dead red snapper, and this is Nautilus pompilius. And also, I'm just gonna make a remark, you know, these animals have cute shells, but every once often in someone's house, I see this shell as a curio or a gift or a whatever. I just want to smash that house up with a hammer. Don't do it, man. You're fueling the exploitation of these gimbies. And by the way, there's another species of Nautilus, the bearded Nautilus, the Allonautilus scrobiculatus, which is characterized by a more buff, gnarly body plan, tough, thick features, and it has a kind of beard-like growth of either seaweed or soft tissue covering its body. And, you know, I would bet actual money that we have more Nautilus species awaiting discovery in the world's deepest oceans. 400 million years of survival. And then you have this minor group that are kind of more divergent than nautiloids, but still going towards another branch, another side branch in the mollusk cephalopod family tree, Bactrites, the species, and the clade name is Bactritida. Okay. Well, I guess these were like basic Nautilus-like things. This fossil has turned into an opal-like mineral, and it's interesting. But then we get to the main deal. Ammonites. Even the name is full of kind of mystery and a kind of almost arcane aura. And it's no wonder, because the name comes from Ammon, the ram-headed god of the ancient Egyptians. So Ammon had the head of a ram, and its curling ram-like horns must have struck the fancy of a 18th or 19th century geologist. And in 18th and 19th century, everyone was all about classic mythology all the time, so this group was named the Ammonites. And they're extremely, extremely diverse. I mean, this is a regular one, Macrocephalites. But there are hundreds of species of Ammonites. If I was to count them all, we would need like 5 goddamn podcasts right here. So, yeah, it's a kind of regular ammonite here. And once again, the ammonites differ from the nautiloids by the way the chambers connect to each other. You remember I told in the nautiloids it was a channel running through the chambers as the animal grew. Well, I'm doing the opposite way, but whatever. So in ammonites, there's actually a parallel channel running in tandem with this series of chambers. It's like a common pipeline that accesses all the empty chambers of the animal. And look, I'm no ammonite scientist, but I guess it gave them more buoyancy or maybe more developmental flexibility, because these animals are extremely diverse. I mean, you have some enormous forms like Titanites shown here. It's about as big as a truck tire. Here's a museum model. If you saw it, it would probably look like a mollusk trying to be a sea turtle or a sunfish. Then you got the very, very famous Cameroceras, which is also known as the giant orthocone in this documentary that many people must have seen, Sea Monsters. So this is actually the fossil of Cameroceras. So you could see that's 1 centimeter here, and this is its section. So it was like a big, long jousting pole of a mollusk. And yeah, here is a screenshot from that infamous documentary. Now, these animals, at least in some forms, really did grow this big. But I don't know if they were like these giant squid analogues. The soft body is lost forever. So you're forever free to make up how they may have looked like in actual life. Another form, one of the giant spiraling ammonites, is Parapuzosia, here seen with a Victorian gentleman. And once again, these were enormous, but were probably slow jellyfish-eating things like sea turtles and sunfish we have today. I don't think with these heavy shells they were doing the vicious giant squid trick anytime back then. And then it gets really crazy. So I've shown you either straight up or curled ammonites so far, but there were a huge diversity of ammonites called the heteromorphs. Now, these aren't a family name. This is just a term given to ammonites with freaking strange shapes. And they look like every instrument you could name from the brass instruments section. Spirals, curves, giant paper clips, things that look like a baboon embryon or something like this. They're all here. And it gets even stranger. I mean, I cannot imagine the animals that lived in these things. Were they really fast swimmers or drifters, or maybe they crawled along the seafloor, or something we can't even imagine at the moment? Here's some heteromorph ammonites. Anisoceras. Look at this guy. How heavy metal can you get? It's been thought that maybe these spikes help rest it on the seafloor, and maybe it was a kind of bottom crawler, but once again, no one knows. Another, look at this, Hamites. What's going on? What are you doing? Oh my god, this is the weirdest of them all. Nipponites. You probably have heard of this guy. And wow, look at this. I mean, it's like there's a weird geometry to this actually. It's like interlocking U's spiraling forwards or whatever, but really this is a wonder of nature. It's one of the animals that are in my top 5 list of extinct things that I would have liked to see alive. And here's this amazing painting by Emiliano Trocco. He also does these other amazing paintings of dinosaurs, and he has got this very fluid, almost, dare I say, Lovecraftian style. And here is his vision of Nipponites on a beach. Din, 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 din. Look at what I can't even begin to imagine. And of course, I'm not alone. So there's a very weird German researcher. He's an engineer, Klaus Ebel. Google his name in brackets and you will see. So this guy, among other things, believes that a giant shallow sea covered all the world in dinosaur days. Okay? Another theory springing from this world ocean shallow sea idea Mr. Ebel has is that all dinosaurs, including velociraptors, T-Rex, apatosaurs, were swimmers. They were aquatic animals in his mind. And he thinks that only the dinosaurs with sails on their backs could support their weight on land. I don't know why, because he's an engineer and a bridge engineer, and he's looked at a drawbridge and he says a bridge can support itself with a tall sail, and so only dinosaurs with sailbacks must be able to support themselves. Now you may ask, why does this have anything to do with ammonites? And it's this. So according to Klaus Ebel, none of the ammonites had tentacles. No, they were giant snails. Looked like big fleshy mounds of flesh with eyes that just crawled on the seafloor. He gives an example of these weird heteromorph ammonites, and he says these weren't aerodynamic. So ergo, in his very strange logic, all ammonites must have no tentacles and be these giant snails sharing a globe encompassing shallow ocean with dinosaurs, none of which were strong enough to venture onto land, except for the spiny-backed ones like Spinosaurus. According to Klaus Ebel, only Spinosaurus and Ouranosaurus and a few others were able to walk and land. God. Anyways, then we come to the great radiation of cephalopods alive today, the Coeloidea supergroup. And I will tell you more about them once I back up this segment, and we'll be back. Let's rock! Okay, now we were just about to speak about the main group of cephalopods alive today, the Coeloidea supergroup. Now, just to refresh, we've been talking about the earliest forms: Tanuella, oncocherids, nautiloids, ammonites, the little-known bactritides, so on and so forth. As you can see, there are some other groups I just didn't get to mention. So now, this massive group encompasses all present-day living cephalopods, except for the nautilids, and also a few extinct guys, the belemnites, the belemnoidea group, extremely common dinosaur era squid-like things with very hard calcified shells that look like bullets in their backs. In fact, when I was little, I used to see the pictures of these belemnite shells, and I was told it would be like, man, the 50! Like these giant 50 caliber machine gun shells shot about in the world's oceans in the past. But of course, they weren't ammunition, they were cephalopods. And in fact, there's something really artistically attractive about the shapes of these things. They just seem like things you want to have and, use as a paperweight or an office ornament or whatever. And, since all belemnites are dead, if you get some as fossils, it's ecologically friendly too. The artistic beauty of belemnites hasn't gone unoverlooked. Wayne Douglas Barlow, the undisputed master of fantasy art, uses them frequently in his paintings of hell, usually demons or their minions in Barlow's hell have these floating belemnites arranged in a crown around their skulls. So I think it's a neat detail to notice about this awesome group. And a lot of belemnite fossils are also known with either soft parts or impressions of hard spines in their tentacles or jaws. And as you can see, the jaws seem extremely oversized for an animal with a shell this big. Well, the biggest belemnites were around a meter long in their shells. This is Megateuthis, one example. And it's known from the late Cretaceous, the same seaway as all the mosasaurs in North America. Okay, now the jaws here might seem oversized, but it's only because the animal was way more bigger than the shell. So here's another form, Acanthotheutis, and you can see the teeth-like things in their tentacles. So they were really mean and fast critters. But if you look at Acanthotheutis fossils, you see the spike is only 1/3 or even less of the animal. So in real life, these things looked basically like squids or cuttlefish, and you weren't able to see the bullet-like shell unless you cut one open. And this is why, for example, there are, to the best of my knowledge, no belemnites with curly shells. Here's another example. This is either a belemnite or a belemnite on the road to becoming a squid or cuttlefish-like form, Phragmoteuthis, and you can see that its tentacles were lined with these awesome, vicious, spiny things. I mean, just look at these things. Each looks like a dinosaur claw or a tooth. Mean creatures, all of them. Here's another form, Leptoteuthis. Unless I'm mistaken, this is closer to cuttlefish. And of course, there are forms that are closer to octopi. Proteroctopus, Keupia, almost an octopus, but scientists have discovered the vestiges of a very thin, stylus-like supporting element in its bulbous head. And of course, this fossil is remarkable for being preserved with an ink sac as well. And then we get to animals that are alive today. Behold Vampyroteuthis, the so-called vampire squid, with this amazing Lovecraftian glowing eyes, weird umbrella-like tentacles, and little finger-like protuberances instead of suckers on their tentacles. Now, just to go back on our family tree, look at belemnites and all those. You see, belemnites are a sister group to cuttlefish and squid. Vampyroteuthis, the sole representative of the group Vampyromorpha, is actually closer to octopi. It's not classified as a proper octopus because Vampyroteuthis, invisible in this picture, has two tiny squid-like tentaclets tucked away outside its umbrella of weird mouth-like tentacles. And it also has two light organs that glow like big eyes in the dark, and two fins on its head. Very, very curious. I mean, this animal is kind of become like a poster child, so I don't want to speak too much about it. The web is full of text about Vampyroteuthis, and it's a very cool animal. When the first samples were caught, scientists assumed it to be a gelatinous, blob-like, drifting, kind of slow and inactive creature. But then it was observed by submarine cameras, and it was like a little bumblebee buzzing about with its head-mounted fins. Although there are other videos of it online, and they show Vampyroteuthis in a slow, kind of inactive mode. So it's basically leading a very dark and cruel life in the depths, just drifting about, or if necessary, swimming rapidly and eating things. Okay, then we get to proper octopi. Now this is one of the two major divisions of octopi. There are Cr8 octopi, which look a bit like Vampyroteuthis with their head-mounted fins and strange tentacles growing in their arms beyond their suckers. And there's only a few species, well, only a few genera of them known. This guy, Ophistoteuthis agassizi, is one of them. This is the very famous Dumbo squid that you see in these weird clickbait articles like 10 creatures you can't believe live under the sea. Well, here's one of them. And the genus Ophistoteuthis has a very wide variety of forms, and these are all very deep sea animals. So I guess the species which we have named actually represent a minority of the exact diversity of this group. The Cr8 Octopi. Now if you go to our map, cladistic map, we have Cirroctopoda. These are what I'm talking about. So they're outside octopi proper, but more inclusive than the vampire squid. So we go and let's explore Cr8 Octopus diversity further. There are some really amazing forms in this group. Look at this. It looks like a radar dish or a science fiction solar sailing sun ship. Cirrothauma murray. And the name is wonderful too. Cirrus or Cirrus means little tentaclet, I guess. And thauma means wonder. And this guy's tentacles around its mouth are lined with biolites. How cool is that? And here's another Cirrothauma, and you get to see here why this group has the name Cr8 Octopi. You see their suckers are surrounded on two sides by even smaller tentaclets, the cirri, and they have got two big Dumbo-like fins. Now I look at this body plan and I wonder why there aren't any Cr8 octopi with like enormous, like each tentacle has 100 more tentacles coming out of it, kind of weird, like a Medusa's head. And I don't know, I guess just they never evolved it, or maybe too many tentacles means too many nerves to control them a bit. And here we go, another Cr8 octopus, Stavroteuthis cirtensis. Now I've shown you all named genera of Cr8 octopi, and there are a few. And as I told you, this is not going to be the case with octopi or squid. We're going to breeze over their diversity because there are just so many species, literally hundreds, if not a few thousand species altogether. And their exact details are only known to zoologists and cephalopod scientists. So if you're a young viewer and if you're in school, if you like these things, you might want to consider a career in zoology or marine biology. And here we go. Now we're in the proper octopi. So now these guys are like octopi. And of course they have so many amazing things we could say about them. They can change color, shape, but I'm going to show you more of the obscure and little known octopus species. For example, this is Volcanoloctopus hydrothermalis. They live around these hydrothermal vents in the depth of the ocean where no sunlight penetrates. And there are these entire ecosystems that depend not on sunlight but on the chemosynthesis of the minerals and the gas that come out of these vents. And there are these giant bloody worms and strange blind crabs, and Volcanoloctopus lives among them. Now you see there are two octopi in this picture. The bigger one is the female, the larger one is the female, yes, and the smaller one is the male. That's the way it goes in Octopus Town. In most cases, males are way smaller and disposable compared to the females. And okay, now just to make things more confusing, this guy, Vitrellodonella ricardi, the gelatinous drifting octopus or whatever you want to call it, looks a lot like these guys, the Cr8 Octopi. You know, like them, it's kind of blobby and it's got this web and all that. But look at its tentacles. They got pure suckers, none of the surrounding cirri. And their heads lack the fins that Cr8 octopus have. This is an incirrate octopus of the proper Octopusi octopus group. But of course, just to make things more complicated, like all animals, octopus have such a variety that you have derived forms that look actually more like the basal forms but are actually derived forms, and the similarity is only an effect of their similar habits and lifestyles. And I'm getting ahead of myself. And of course, let's look into some superlatives. What is the biggest octopus? What's the most strongest octopus? It is the giant Pacific octopus, Enteroctopus delphini. And this guy is really huge, really smart. If I'm not mistaken, it lives in the Pacific coast of Canada and possibly also Russia and wherever. And it's a beast. I mean, Google its name and images and movies if you want to learn more about him. And of course, there's always, the world of octopi has always had this weird wonder, a kind of cryptid, the giant octopus, Octopus giganteus, the thing of tall tales and strange news. And why is it impossible, they say? You know, you got quite large octopi, so why not 10-meter long octopi in the very depths, the abyss of the ocean? And in fact, I remember Arthur C. Clarke in one of his books made a prediction about, so I don't know, something happens, they go to the deepest ocean, it's actually a byproduct of the whole story, and they see a 100-meter long octopus there or something. Now, it's not impossible, I'll grant you that, but it's highly unlikely. And the giant octopi that have been found on the world's beaches have all turned out to be decaying blubber tissue from whales, or more particularly sperm whales. You know how sperm whales have this big blocky nose, don't you? Okay, so when the whale dies and that thing comes up and there's this fat and ligaments, whatever, it looks like a dead octopus. But, you know, we know so little of the ocean's depths. Maybe there's not a school bus-sized octopus down there, but it's not impossible for there to be an octopus even larger than the giant Pacific octopus to be living somewhere. We'll just have to wait. I guess only 8% of the deep ocean has been explored or whatever. All the more reason for you kids to be educated more about octopi and pick up marine zoology if you wish as a career. And education is really important these days. Now, what's going on with this picture? Can you tell? There's something horrible. Look at this guy. Look at what I don't want to say this, but what a moron. He's holding one of the most dangerous animals on Earth, Haplocina species, the blue ring octopus. It has a neurotoxic venom, so potent, so dangerous that, I mean, look at this. God damn it. Listen to this poem. Close your eyes. Give me your hand, darling. Do you feel my heart beating? Do you understand? Do you feel the same? Am I only dreaming? Or is this burning an hashtag eternal flame? Well, I guess these would have been William _Exotic's last words, if this little octopus had decided to bite him. This is one of the most dangerous animals in Australia and probably in the world's oceans. If it had bit him, William Exotic would have died, paralyzed, self-aware, but he would have realized that his lungs are not responding to the commands of his nerves because Haplocina has injected them with a fast-acting, deadly poison that retains awareness in his brain, but no muscles respond, not even the involuntary ones. So you slowly watch yourself die. So if this octopus was in a bad day, William Exotic would have expired by the time he would have gotten to close your eye. Okay, moving on with Octopus Diversity. Then we have the very famous and amazing mimic octopus. I mean, there's so many pictures of this animal and it's extremely smart like most other octopi, and it has this uncanny ability to mimic the forms of sea snakes, soles, crayfish and other fish. It's a very smart animal. Just Google this name, Thaumoctopus mimicus. This one shows a pregnant female protecting her eggs. And you can see the eggs actually have little eyes visible. There are gonna be a lot of little octopi. And I've just picked a non-mimic picture of this species because the internet is awash with images of this animal mimicking other animals. Go see them for yourself. Going on with Octopus Diversity, Tremoctopus, the blanket octopus, a very little known open sea animal that has webs between its arms, and it basically drifts like an endless voyage undertaken by a blanket that's undertaken an endless voyage into the weary, into the void. I'm getting pretty late and I'm getting a bit sleepy, so sometimes my speech slurs, but I think it's slurred at the right species, doesn't it? I mean, this whole animal and its whole lifestyle and its whole appearance resembles nothing less than an endless LSD trip with some sort of new wave song playing in the background. Like this, we go. Okay. Where are we? Another octopus. We have the giant Antarctic octopus, Megalelodone sedapos. The big guy is a female. If you notice, she is quite large. But here we have a Gimby. What are you doing? He's the male. I guess that's one rule in Octopus Town, that the males are always smaller. Moving on with Octopus Diversity. I mean, there's just so many kinds of these guys. The genus Octopus itself has, I guess, more than 100 species. And there's a very, very famous book, the Cephalopods, A World Guide. And if you look at its pages, the octopus section is, I'm not kidding, like 20 pages full of octopus species unknown 1, octopus species unknown 2, octopus species number 3. The diversity is amazing and even now unexplored. I mean, this mimic octopus I showed you, it wasn't properly understood in the beginning of the 2000s. So there you go. So Octopus macropus is one of these extremely nicely colored octopi, but like many others, it can change color at will. Then we have the very interesting Cr8 Octopus, a really smart dude, able to build houses out of coconut shells, I believe in the Indian Ocean, and it has this added ability to glow in UV light. So its suckers, you see, cast this eerie psychedelic glow when illuminated by a UV flash. I guess if we illuminate things with UV flashes, we will see a lot more colors, lights, and patterns where we hadn't noticed them before. And then, of course, there's the really, really weird one. Okay, so evolution has this weird trick, okay? Argonauta. Look at this. I mean, it has a shell, just like the ammonites or the Nautilus. You would expect it to be related, but no. It's actually a member of the proper octopi. It just secretes this hard substance from its tentacles. So it's not part of its backbone or whatever. It builds a paper-thin, calcium-rich shell with secretions of its tentacles and then drifts in the open sea. That's why it's named Argonauta, after Jason and the Argonauts fame. You know, Jason sailed the seas in a ship named Argo, and his sailor buddies were called the Argonauts. So they were Jason and the Argonauts, and they had many adventures together. And this is what Argonauta looks when he's naked. Look at it. Pretty embarrassing. And it's very interesting how the set of arms that make the shell have widened into this sort of fleshy two-fold cloak. I mean, one of the secrets of the success of cephalopods in general is that they have this soft and extremely malleable body plan. From the same tentacles, you could have light organs, tentacles, little tentacles, cloak-like things, things that secrete shells, things that glow in the dark, and the list is just endless. And of course, tentacles are also used in the octopi for a very necessary subject that we humans have come to consider nasty. Male octopi have one arm turned into what is called a hetocotylos, and this arm works as its genital. So you can see this octopus species, Abdopus aculeatus, and the male is getting it on here, right now, right before your eyes. What you gonna do about it? But I guess if we had as versatile reproductive systems as octopi, maybe reproduction wouldn't be such a sin. But here we are seeing the role of octopus tentacles in sexual reproduction. And then we have the really weird one. Wee 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 wee. Pick pick pick. Spirula spirula. Now let's go back to our weird cladogram. Why do I put this so back? Okay. So now we've covered all the octopi and all the belemnites and all the others. But you see, nestled outside the group that makes up squids and cuttlefish, you have something very strange, spirula, a kind of holdover from the past, known from only, I guess, one or two or a few species in the deep ocean. Spirula looks like a little cuttlefish, but inside its head, it has this coiled, weird shell that is a straight up vestige from the age of the ammonites and the nautiloids. It's a unique, entire group of the cephalopod clade, which we will explore now in the final orgiastic burst of diversity in squid, cuttlefish, and their relatives just after I back up this video. Pick, pick, pick. And now it's squid time. Now, we've come so far to the main groups of squids, or the decapods or decabranchia, or whatever you want to call them. These are characterized by having 8 tentacles and 2 arms to catch food with. But you will see that in some cases this trend is reversed. So anyways, we're gonna look at squid first. Squid, as we properly know them, come from 2 distinct lineages. The first of which, Oegopsida, is extremely, or dare I say, obscenely diverse. I mean, if we were just to look at Wikipedia, the Oegopsida group has so many families. And if you go to like one of the families, there are like 60 species and all these genuses, and like all these genuses have all these species. So it's a very, very diverse group. So without much ado, let's go. Now, this is one of the strangest because it has these side fins and they all have these comb-like structures. Ctenopteryx sicula also has a kind of Lovecraftian name. So this guy stands apart from many other oegopsid squids because of these weird comb-like head fins, let's say. And then, of course, you got the group containing Architeuthis, everybody's favorite giant squid. This is a very famous group of large-bodied, somewhat active, predatory, rapacious squids. Here you see Architeuthis in Japan, dying as it clings to a rock. This was taken in 2004, and it was one of the first times this animal was photographed properly. And of course, here you have this, which comes a few years later, brought up with a ball of bait. And it's a really fearsome creature, but not so fearsome as the Humboldt whales. You know, there are some bottlenose whales or sperm whales that eat these guys up like calamari. And in a separate family, I showed you a lot of weird families before. Well, this is one of them. You got Octopoteuthis. Now, I told you that squid and relatives have 10 arms in total. But these guys have lost 2 of the long arms and they only have 8 tentacles. A bit like octopi, but independently. And they live in the deepest ocean. And of course, a related group with also 8 arms is the one that contains this really amazing spaceship-like giant squid. It's as big as a coffee table, so not an enormous squid like Architeuthis, but nevertheless, Taningia has these glowing tentacles and 2 lemon-sized clubs, which are arguably some of the biggest light organs in the ocean, and it's just like a spaceship out of Blade Runner 2049. I mean, all these animals' lives are spent like, if you watch the 2017 film Blade Runner 2049, it's like one of those spinner cars in that films. And when these guys are swimming about and catching and eating other squids or fish with their light-lined tentacle mouths, I'm sure like an endless this kind of dubstepy music plays in the background. Or maybe it doesn't. But Taningia is a fascinating squid nevertheless. More groups in the Oegopsida. Okay, you got the Cr8 family, also known as cockatoo squids. They are a very, very strange family, known for their bulging eyes, extremely simplified, transparent anatomy. Here's one species. And here's actually an extremely specialized species. It has 2 tentacles. It's like somebody made a drunk drawing and it came alive. Look at it. But also it's interesting to note that in both species there's this kind of upright organ. It's, I believe, their liver. And it controls the animal's buoyancy, and it helps them find their direction and orientation in the deep ocean. And these guys basically live like jellyfish, just drifting by, eating whatever that comes to hand. But of course, this same family, the Cr8 family, has also this. Megalocranchia. Look at it. Look at this guy. What are you doing? It's amazing that this giant, human-sized squid is from the same family group as these little... I mean, what's going on? This is why squid are so interesting, because they have this unbelievable plasticity in evolution. And look, this is just one family. It's like the equivalent of, let's say, dogs the size of your fingernail living in the same world with dogs the size of trucks. I don't know. That is the level of size disparity between these species and this guy. And of course, if the analogy was to be extended, the small dogs would consist of only one leg and a fang or something. I mean, look at this. Look, and I can assure you that many others like this must be lurking down there. We're only scratching the surface. Let's go. Vampyroteuthis, another family. Onychia robusta, the giant Russo-Japanese squid, related to Architeuthis. Sometimes actually this picture is used as a picture of Architeuthis, but no, it's not from the same group. Dosidicus gigas, the very famous Humboldt squid. Here a diver is trying to make them kiss, but they're actually extremely vicious predators. Look at it. It's just cut a tuna fish in half. And tuna fish themselves are like vicious animals. I mean, phew. Okay, moving on. Philippovia, another large squid that's usually encountered in Japan, that's distinct from Architeuthis or other forms, but here we are. They don't normally appear on beaches like this. This was a beach specimen and it's quite dead, as indicated from its reddish color. Okay, so one of my guilty pleasures is calamari and octopus. Oh, they're delicious. But octopi are so smart that I just feel awful eating them. So I've given up eating octopi, but squid are still in my menu. And I've always wondered if we could have these table-sized squids and, have enormous calamari rings and eat them forever. Wouldn't that be grand? It turns out no, because the giant forms have so much ammonia in their flesh that they're basically inedible. I mean, if you were to cook them enough to drive out the ammonia, then they would shrink down to the consistency of shoe soles. So they would be extremely hard and no use eating. Oh well, I guess we can all cope with little disappointments in life. Okay, moving on. You think we're done with Oegopsida? No. Mesonicoteuthis hamiltoni, the colossal squid. Even bigger than Architeuthis, but not as vicious. But if you've seen pictures, their tentacles are lined with claws that resemble almost velociraptor claws. So really badass squids. But as I told you before, not as badass as the whales that eat them regularly. And another bet I'd be willing to make is that we probably have a few more giant forms of squid lurking in the world's oceans. Okay, moving on. We got the flying squid. Omatostrephis bartrami. Okay, these are actually extremely popular commercial squid too. I mean, I've read somewhere that a related species makes 1/4 the squid catch of the entire planet. And here we have this really beautiful and amazing creature, flying squid. And it's not like squid that sometimes jumps out of the sea. No, it's actually specialized for aerial maneuvers. Of course, it doesn't fly like a bird can fly, but look how aerodynamic it is. And one can't help but wonder if this line of evolution was to be pursued a bit further, could we have really actively flapping flying squid? And Who knows? I mean, maybe, maybe not. But once again, this looks like a work of art. It's beautiful. Moving on, Vampyroteuthis, entire family for this one guy with enormous tentacles, lives in the deep sea. Nobody knows what it's up to, except that it's awesome and sometimes appears in deep sea submersible camps. And Cephalopods, again, with extremely long arms, almost like a squid trying to be an eel. Again, deep sea creature, not much else is known, except that it's wonderful. Histoteuthis, the famous glowing peacock squid. So this squid is lined up with these jewel-like light organs that give out color in a few different colors, and its eyes are famously asymmetrical. So one eye is enormous while the other is smaller and weirder. Here's another picture showing the other eye. Look at this, look at the organs. It's beautiful. And this is also the squid famous for its ability to release a glowing cloud of bioluminescent bacteria instead of ink. So it releases this glowing decoy, and in the extreme dark of the deep sea, it's, I guess, extremely effective. Moving on, we got Vampyroteuthis, another family known for its sword-like extended gladius or soft cartilaginous shell that comes equipped with two comb-like fins that run along its entire length. And it's just doing what it does, I guess. Once again, sometimes you got single species families in these groups. That's how diverse and how little known they are. So if you want to become a marine biologist, if you study squids, you will almost certainly discover new species or even families or even groundbreaking groups. Who knows? Moving on. Again, Vampyroteuthis megalia. So this is like a hyper-evolved version of Histoteuthis, where the skin-based light organs have become enormous and shine in many different colors, and it looks like a 1970s French drawing of a UFO encounter. I mean, look at this. You could almost look at this and say, Les aéronautiques inconnus du monde. And from this you can tell that I know nothing about French. Sorry about this. Okay, moving on. Magna pinna. Okay, this is the weird alien squid that shows up on news every now and then. Its tentacles are almost 7 or even 10 meters long. It's got one enormous head. It hangs around in the ocean's depths. The tentacles hang about like a ghostly chandelier from another world. And it looks like those aliens from Independence Day, doesn't it? Well, nature did it first. These are, of course, not out there to take over the planet, but they're highly sedentary, slow. They're like anglers, basically, hanging about in the depths of the sea, and they're just one more example of how extremely diverse and little known this group is. Mind you, we are still in the Oegopsida group of squids, and the diversity just goes on and on. I've actually skipped some groups when I'm compiling this list, but if you go to Wikipedia or the Tree of Life website and just individually spend time to Google all the groups one by one by image, you're gonna see wonders. You're gonna see wonders that will make this video look daft in comparison. Alluroteuthis antarcticus, another Antarctic squid that has secondarily lost its long tentacles. So it's got these kind of carrot-like fat and slightly immobile arms, and it's just chunky, and it just drifts about. And that's all I could say about it. But also look at these guys from a kind of visual perspective, like how many options are being explored here. And yet the body plan is still common. This is really fascinating about the entire cephalopod group in whole. And you know, we looked at all these prehistoric forms too, and guess how many weird, wonderful one species families were alive back then? We're never gonna know, because 99% of life doesn't get fossilized. Anyway, moving on, we got Cephalopods, another little known rhombus-shaped squid that's known more by its gelatinous egg-like egg sacs that divers usually encounter. The squid is rarely seen, but the egg sacs, if you Google them, are pretty occasional. Alright, moving on. Now we've come to the Myopsida group of squids. And the difference between these guys and the Oegopsids, well, it's difficult for me to explain in my layman terms. Suffice it to say that the Myopsids are slightly different in the makeup of their eyes and shell, I guess. But you need to consult a zoologist to make absolutely certain. And the Myopsids make up some of the most common commercial squid species on our planet, but they are not as diverse as the Oegopsids. Here's an example, Loligo vulgaris, the common squid. Good eating though, good eating. And another Cephalopods lessoniana, another Myopsid, but this is what they generally do. They have more lightweight head fins, and I mean their body architecture doesn't devolve too differently from this guy or this guy. That's it. So now we are moving to the families that contain cuttlefish and a few other tiny groups that are their close relatives, and we're about to come to the conclusion of our cephalopod thrill ride. I mean, how far we have come from all the fossils to the present day, and this was just scratching the surface. So we have this Cephalopoda group, the kind of little cuttlefish-like, squid-like group that are distinct taxonomically from all of them, which includes Idiosepius paradoxus, the Cephalopoda group, the midget squid, or the midget cuttlefish, or whatever you want to call it. These guys are very tiny. I mean, smaller than a rice grain in some cases. And due to complex taxonomical and anatomical reasons, they have a family level group all of their own. So they're as distinct from other squids as all Oegopsids were from all other things in this tree you see right here. Moving on, we got the jewel squid or the jewel cuttlefish, Euprimna berrii, again part of this distinct cephaloid grouping. And then you got the proper cuttlefish. So you see the cephaloids were like halfway between squids and cuttlefish. And of course, a great difference between cuttlefish and the other guys is the presence of a calcium-rich cuttlebone that lays beneath their bodies. And this is actually what budgies like to chew on in their cages as a toy. So this is a majestic species from the true cuttlefish group, the giant Australian cuttlefish, extremely smart. In fact, there was a science fiction book in which these cuttlefish get sent on a self-regulated asteroid spaceship and they develop sentience or whatever. I think the writer was Stephen Baxter, but anyways, forgettable story, unforgettable animal. The way these guys change colors, communicate with each other, suggests an extremely high level of intelligence, possibly as smart as a child, really. And then the true cuttlefish group is also really diverse and really underexplored too. We got the Metasepia, Pfefferi, the jewel cuttlefish, and sometimes these species have little leglets. Oops, I haven't gotten there yet. So sometimes these species have little leg-like protrusions that they actually walk on. And that makes them look extremely bizarre. So, guys, believe it or not, we've surveyed all the major groups of cephalopod diversity and evolution. And I hope I've been able to give you the basics of how diverse and how old and how vast this group really is. And even among present-day species, we still have a lot to explore and a lot to uncover. Which brings us to potentials of future evolution. You know, most of you are probably interested in speculative evolution, the hobby of speculating about evolution. You know, how would life develop if dinosaurs hadn't gone extinct, or could we have land-living squid, and so on and so forth. And of course, it's a cottage industry within the little Renaissance fair of speculative evolution itself to come up with terrestrial cephalopods, because these animals are so interesting and so bizarre and so wildly divergent from all other life forms that we just want to see more of them. So here's an example from The Future is Wild, the famous TV documentary from BBC. The swampus, the swamp-dwelling octopus with 4 arms evolved into pads that carry its weight, and 4 arms that help it grip things and help it pull it forward. And almost every speculative zoology or future evolution artist has considered this scenario once. I mean, for example, in this French book, The Main, Animaux dans le futur or something, which means, I guess, God damn the animals of the future. But no, it means actually today, the animals of the future. You got this almost whale-like cuttlefish with tentacle sections that have evolved into jaw-like coverings, and they're very smart and dexterous. So that's another example. And the examples can be multiplied, really. I mean, I could give you a whole presentation as long as what you just seen on speculative squids and their descendants. But for example, the inimitable Satoshi Kawasaki has come up with this 8-legged horse-like land squid. And I think this is really important, because when people design squids or octopus that live on land, they inevitably transport this tentacle limb to land. So you got something that walks on tentacles, like a War of the Worlds tripod. But it turns out limbs don't really work this way. Even when octopi are pushing against hard surfaces, their arms assume this kind of briefly jointed, rigid appearance. So if we were ever to have land-living squid, their tentacles would assume rigid forms that are more like legs than true tentacles. I'm sorry, but that's just how physics work. And here's another land-living squid by Andrea Claudio Gassler, also known as Junior Woodchuck on DeviantArt. And it shows a lion squid that has actually evolved its hind fins and 2 tentacles into rigid limb-like structures, and it runs about and chases its prey. Well, guys, we could talk a lot more about speculative squids, but I hope you liked this video. I really work hard for this, and actually, a lot of my work went into thinking, I'm making all these videos, recording all this sound. God damn, why am I wasting time editing the videos? And then I realized, well, why don't I just make the images, you see? I just made a lot of JPEGs, and I'm just lining them up, so the file names actually look like this. Wait, okay, here's my folder. This is actually how you can make similar tutorials. So you see, I just have JPEGs. Just have a consistent typeface, just make picture after picture after picture, line those guys up, and just record your screen with a good microphone. You don't need to edit anything. You can make these videos extremely visually attractive and beautiful and consistent and well edited without having to use editing software. So that's my tip for you. Tip number 1. Okay, what other questions may you have about cephalopods, or what other animal groups would you like me to cover in this fashion? Because now that I've come up with this technology to make cheap and efficient edited videos, I'm gonna go hit the town with this. I'm gonna make many diversity videos like this, I hope. Also, guys, if you watched so far, thank you. Now, I don't like panhandling for money much. And, thank heavens that I actually work another job and I can make my own living. I mean, I don't have any urgent needs for money. But recently, I'm working on a new book. This book is completely unrelated with cephalopods, speculative zoology, or whatever. But it's something that I worked on for the past 5 years or more. It's about Istanbul's architecture. So a bit of a niche subject, and it's an academic book. It's not a popular art book. Although when it's complete, I will show it to you. It's pretty intense. But anyways, necessities have arisen to such a level that I have a publisher on board. I just need $4,000 to launch and produce this book because it's extremely picture rich. It's over 1,000 pages long, and every page contains many colorful pictures. In order to make this book, I'm just looking at any source of money, okay? And I guess this video will attract a lot of attention. So if you can support me. Now, I don't like panhandling. I don't like to do all this Patreon or Indiegogo things, I think there's a taint of dishonesty about them. I just want to make enough money, $4,000, to make this book. If you donate money, your name will be in the creditors list. And my academic books get to major libraries around the world. Ivy League colleges buy them, national libraries buy them. So your name will be in those libraries. And I will send you a personal thank you secret image if you back me. Okay? So, as I told you, I don't deal around with Patreon or none of that. You can send me money by Western Union or a straight up bank transfer. And if you like me, if you like my work, if you like to support this book project, please contact me at c.m.kosemen@gmail.com and we'll talk. If you give a huge amount of money, I will dedicate a section of the book's cover to you. You will be listed as a co-publisher. Okay, so that was Cephalopods. That was an interesting podcast, I hope. Thank you all for watching, and please like, comment, and share my video. I have a feeling that this video will be very popular. So there. Lots of love. Cheers. And as always, don't let the squid... I was going to say something funny about squid, but okay. Squid are amazing. Research them. Goodbye.